Hello students. So next we are going to find out the derivative of trigonometric function, and the first one as usual we will take fx is equal to sin x. Okay. So what is the derivative of sin x? The beginning is always same, that is we know that the formula of first principle f dash x equal to limit of x tends to 0 and f of x plus h minus fx by h. Now since fx equal to sin x, f of x plus h will be sin of x plus h minus sin x. Actually after this step we have to apply the trigonometric formula that we have found in chapter 3. What is that formula? Sin c minus sin d. Anyone remembers? Sin c minus sin d equal to, what is the answer? It is 2 cos c plus d by 2 and sin c minus d by 2. So this formula we have to apply in the numerator. That is, we will write down limit of h tends to 0 sin of, sorry, it is not sin, it is 2 cos x plus h plus x by 2, that is 2x plus h by 2 and sin of x by 2, h by 2 divided by h. So we have directly applied the formula that we have written on the right hand side. After this step, we should think how to deal with this limit now. We see that this part cos of 2x plus h by 2, it is a part of direct substitution, and the next part, that is sin of h by 2, and here we have h. We have a formula of sin of x by x, right? But here it is h by 2, here it is h. So what we will do in the next step, this 2 will bring it down. Alright. That means what I have done, I have combined this 2 with the denominator h, and cos x, 2x by 2 is x plus h by 2. Now in the next step, what I am going to apply, the algebra of limit. This limit is product of two functions, one is cos separately, one is sin h by 2 by h by 2. I will do the limit of product is equal to product of the limit, that I am going to apply now. So here we have the next step now. As I said, limit of a product is product of the limits. So one limit is applicable to cos x plus h by 2, another limit is applicable to the another function. So for the first case, h tending to 0, so you can write down it is only cos x. In the next case, we know that this formula is applicable only when this x and this x, all three of them are same. Alright. So in this case, this h tending to 0 I can also write down as h by 2 tending to 0. That means this value is equal to 1. So this is only cos x. So therefore finally you can write down ddx of sin x is equal to cos x. So this is the actually formula, first formula of trigonometric function. So next is the next function of trigonometry, that is cos x. So the beginning is same always. What is the beginning? So the beginning is f dash x equal to limit of x tends to 0 f of x plus h minus fx by h. Now you have to put the functional value. See, if fx equal to cos x, what is the value of f of x plus h? That would be your cos of x plus h minus cos x upon h. So like in the previous case, we have to apply the trigonometric formula here. I hope everybody remembers what is the formula cos c minus cos d. The formula is 2 sin c plus d by 2 and sin d minus c by 2. So we are supposed to apply this formula now in the numerator. Okay, so limit of h tends to 0, 2 sin c plus d by 2. That means I am going to write down 2 sin 2x plus h by 2 and sin x minus x plus h, that is minus h by 2. The entire thing will be divided by h. Okay, we have directly used the formula that I have written on the right hand side. Next, what are you going to do? You see, this sine में angle है h by 2 and also there is a minus sign associated with it, and we know that sine of minus theta is equal to minus sine theta. So this minus sign will come out, and this h by 2, this 2 I will bring it down. So in the next step I am going to write down minus of limit of h tends to 0, and this is sine x plus h by 2 sine h by 2. The entire thing is divided by h by 2. I have brought the numerator 2 to the denominator. So now it is very easily visible that I am going to combine sine h by 2 with h by 2, and this function I am going to separate it out. So here we have the next step now. As you can see, I have done the algebra of limits here, because limit of product is equal to product of the limits. So in the first case it is a direct substitution, so minus sine of x from the first case. Second case, as in the previous case, I can write down x tends to 0 is h by 2 tends to 0. So this value will become 1. So the remaining is minus sine x. So you can write down the conclusion remark now, that is ddx of cos x is equal to minus sine x. So far we have found the derivative of two functions, sine x and cos x. So by default, what is the third function now? Tan x. Yes. So the third one, we see fx equal to tan x, and the beginning is always the same, the formula of first principle. Now we have to insert the functional values, that is limit of h tends to 0. If fx equal to tan x, f of x plus h will be equal to tan of x plus h minus fx upon h. In fact, in place of fx, I should write down tan x, because it is fx equal to tan x. Okay. Now we know that there is no formula for tan c minus tan d, like there is a formula for, sin c minus sin d formula is there, cos c minus cos d also formula is there, but tan c minus tan d there is no formula. That means this expression of tan we have to convert in terms of sin and cos. That means I can write down limit of h tends to 0, this tan matlab sin of x plus h divided by cos of x plus h minus sin x upon cos x. The entire thing is divided by h. In fact, whenever we come across the trigonometric function of tan one function minus tan another function, we have seen in chapter 3 also, always we go for this conversion. That means we have to convert in terms of sin and cos, because there is no formula like tan c minus tan d. And after this, things are easier now. You take the LCM. If we take the LCM, what we see? This will become cos x plus h by into cos x, h into cos of x plus h into cos x. Numerator में we have sin of x plus h into cos x minus cos of x plus h into sin x. So this is the way we take the LCM. Now if you look at the numerator carefully, sin of x plus h cos x minus cos of x plus h sin x. some formula it is indicating to us. What is the formula? Sin A cos B minus cos A sin B. That formula of sin of A minus B formula. So that means we can write down the numerator as, so the numerator becomes like this. This is the numerator. We can see sin A plus B minus sin actually A minus B, because sin A cos B cos and cos A sin B. So xx gets cancelled. What is remaining here? Xx gone, to only sin h will remain, which I am going to combine with this h. So it will directly give a formula, and the remaining part I am going to write down as it is, cos x. So I have separated the functions. Now again I can apply limit of product is equal to product of the limits. So this I can write down, limit of h tends to 0, sin h by h, sin of h upon h, limit of h tends to 0, 1 by cos of x plus h into cos x. The first limit is, without any doubt, the first limit is 1, and in the second limit we can apply direct substitution method. So cos x into cos x, we have 1 by cos square x, and you know that 1 by cos square matlab what? Sec square. So sec square x dx. So therefore we can write down ddx of 10x is equal to sec square x. So we have completed three functions, sin x, cos x and tan x, and we see that in case of sin x we can apply direct formula sin c minus sin d, cos x में direct formula cos c minus cos d, but in case of tan x we have taken the help of another formula, because there is no formula of tan of separation like this. So three more functions are remaining. What I am going to do, I will write down the result of those, like what is derivative of cot x, what is derivative of sec x, and what is derivative of cosec. I am going to write down the answers. You can apply the first principle and verify the result by your own. So here are the answers. The derivative of cot x will come out to be minus cosec square x. Like in case of tan x we found it was sec square x. So cot x ke liye minus cosec square x. Similarly, derivative of sec x is equal to sec x tan x. Derivative of cosec x equal to minus cosec x into cot x. So you can apply the first principle and your knowledge of trigonometry of chapter 3 and also the knowledge of limit. To combine these three, you can definitely find out this result. Okay. In the next class, we are going to see some basic formula of derivative, its geometrical significance, and some algebra of derivatives. Thank you.